Hey, Mia, what are those numbers next to the player's name? Right there, where it says 350 thousandths. His batting average? Oh, I get it. So it's kind of like comparing how many times he went up to bat versus how many times he actually hit the ball. I wonder what kind of math they did to get that decimal. Oh, hey there, mathematicians! Mia and I are hanging out watching a baseball game on TV. Come on in. Thank you so much for helping me catch Mia's game-winning home run on camera. Mia's team went on to win second in the league's championship game. Hey Mia, what's your batting average? You don't know. Well, we've been studying decimals, and now that our math superstar is here, maybe we can figure it out. By the end of this lesson, you'll be able to explain the relationship between fractions and decimals. You'll also be able to convert fractions to decimals and vice versa. Let's see if we can figure out how to calculate Mia's batting average. Based on the numbers we saw on TV, batting averages are reported as decimals. What do we already know about decimals? Decimals, like fractions, represent part of a whole. In fractions, the denominator tells us how many parts the whole is divided into, and the numerator tells us how many parts we have. Decimals are similar, but they use the digit's place value to tell us how many parts the whole is divided into, using factors of 10, like 3/10, 35 hundredths, or 350 thousandths. Even though they look different, fractions and decimals still represent the same concept, part of a whole. We've also learned how to add, subtract, multiply, and divide fractions and decimals. I'm sure there's something in our toolbox that can help us here. Mia said that a batting average has to do with how many times a player goes up to swing compared to how many times they actually hit the ball. So the first step to calculating a batting average must be to count how many times a player goes to swing and how many times they get a hit. Baseball players don't get a hit every time they go up to swing the bat, only part of the time. Part. That's a fraction. Okay, let's say a player goes up to bat 10 times and hits the ball 5 out of those 10 times. 10 is the total number of swings or parts, so that's the denominator. And 5 is the number of parts actually hit, the numerator. We can represent these batting numbers as the fraction 5/10. Hey, wait a second. 5/10 sounds like a decimal with a 5 in the tenths place. 5/10. Okay, so let's say a player went up to bat 100 times and hit the ball 68 times. How could we write that as a fraction? That would be 68 over 100, or 68 hundredths, which as a decimal is 68 hundredths. But what if the denominator isn't a factor of 10? If a player goes up to bat 4 times and hits the ball once, that would give us the fraction 1/4. But what operation could we use to change this fraction to a decimal? Pause here and record your thoughts in your guided notes. Of course, fractions actually represent division. This fraction can be rewritten as 1 divided by 4. The dividend is smaller than the divisor, so we'll need to add a decimal and a placeholder 0. Pause here to finish dividing yourself. 1 divided by 4 equals 25 hundredths, so 1/4 is equivalent to 25 hundredths. To convert a fraction to a decimal, we could just divide the numerator by the denominator. Let's try it again. Pause here to convert 5/8 to a decimal. 5 divided by 8 equals 625 thousandths. Great work! This must be how batting averages are calculated. Okay, Mia had 60 at-bats this season and got 16 hits. Pause here to calculate her batting average, rounding to the nearest thousandth. These batting numbers can be written as the fraction 16 over 60, which is the same as 16 divided by 60. After dividing, we get a repeating decimal which rounds to 267 thousandths. That's pretty good, Mia. What if we need to convert the other way, a decimal to a fraction? Luckily, decimal place values give us a quick starting point. Why don't you give it a try? Pause here to try converting 9/10ths, 80 hundredths, and 350 thousandths to fractions. 9/10ths can be written as 9 over 10, 80 hundredths as 80 over 100, and 350 thousandths as 350 over 1000. Great job! To convert decimals to fractions, we just need to create a fraction based on the decimal's place value and then simplify. Two of these fractions are not in simplest form. Pause here to identify those fractions and then simplify them. 9/10ths is already in its simplest form, but 80 over 100 can be simplified to 4/5, and 350 over 1000 can be simplified to 7/20. Nice work! Converting between decimals and fractions is helpful for more than just calculating batting averages. Consider the fraction 7/12 and 8/15. Which one represents the larger value? Decimals can help us compare values. 7/12 is equivalent to 0.583 repeating, and 8/15 is equivalent to 0.533 repeating. As decimals, it's much easier to notice that 0.583 repeating is larger because it has an 8 in the hundredths place, while this one has a 3 in the hundredths place. Fractions, on the other hand, can help us be more precise, especially when a fraction's equivalent decimal is repeating or non-terminating. In those cases, the decimal would need to be rounded, which makes them a little less exact. Fractions can also help us visualize a specific amount. Let's say I told you I ate 0.666666666 repeating of a pizza. How much pizza is that? You might think it's more than half and you'd be right, but just how much more than half is it? 0.6 repeating is equivalent to 2/3, and it's much easier to visualize 2/3 of a pizza, while it may be more difficult to visualize 0.6 repeating. I guess all that talk of pizza made you hungry. All right, give me a minute and we'll go get some lunch. Thanks to your hard work today, Mia learned what her batting average is. And you learned that fractions and decimals represent part of a whole. A fraction can be converted to a decimal by dividing the numerator by the denominator. A decimal can be converted to a fraction by using your knowledge of place value and simplifying. And decimals help with comparing numbers, while fractions help us to visualize a number's value and be more precise. Congratulations! You've almost completed the first unit of this math course. The next lesson includes an assessment that measures your mastery of everything we've learned so far. So be sure to complete the practice questions and extension activities that go with this lesson and the next one so that you're prepared for the assessment. Keep in mind, you can always go back and review as many lessons as you like. I'll see you soon when we start our next unit on percents. Until then, keep stepping up to the plate and swinging for the fences. Good luck on the assessment, and I'll see you next time.